Let's begin right here, taking a look at 2.4, which is algebraic reasoning. What we're going to actually start doing is getting one more step closer to proving whatever's asked to be proved, whether it's a postulate, some sort of theorem, etc. This time, however, we are going to use your algebra to help us prove and solve equations. Now, there are some algebraic terms that we're going to be using, and you're going to actually have to use them when using proofs later on this chapter. The first part right here, we're going to take a look at our vocabulary, is an equation. Now, an equation is a set of variables, could be numbers and variables, and you use to solve for whatever equation variable that's missing. The first thing it says, write your own equation. Well, hopefully you're familiar with a few, like y equals mx plus b. Our slope equation, right? We've talked about, like the midpoint formula. We have another equation that's used as the quadratic formula. Those are all the different equations, right? Or they're formulas that'll help you find certain things. So a formula is an equation that helps you find and solve information: distance, midpoint, area, perimeter, whether it's a square, circle, etc. Right? So those are all things that you should be familiar with at this point in time. Let's take a look now at these algebraic properties of equality. Now, when you do proofs, they're going to ask you, you're going to figure out, am I using the addition property of equality, subtraction? And we can go ahead and abbreviate. You could say addition, and then for property of equality, we could abbreviate that with POE. All right? And remember, in algebra, when you add something, you have to add something to one side, you have to add it to the other. Addition, property of equality. Subtraction, POE. When you subtract things from one side of the equation, you subtract it to the other. Multiplication, division, all of those things are the same thing, right? If you multiply something to one side of the equation, you must multiply to the other. Same for division property. And we have also the substitution property, where if A is equal to B, then A can be substituted for B, or B for A in any equation or expression. As we move along, let's take a look at the distributive property. If I have A on the outside and it's outside next to parentheses, that should automatically tell you that you are going to distribute. So A times the quantity B plus C, you distribute that A and you get yourself AB plus AC. The opposite of distributing is, hopefully you know, factoring. All right? And so sometimes you factor, sometimes you distribute, depending on the problem and what's being asked. These three properties right here are key to your success in solving or executing a lot of proofs. The first off is the reflexive property. Okay, now think of like a reflection where things are the same on both sides. When I say both sides here, I'm talking about both sides of the equation. So A is equal to A. Same. You could apply it to real numbers. You could apply it to segments. So we could say segment AB is equal to segment AB. And this also applies to angle measures, where we can say angle A is equal to angle A. The next one we have is the symmetric property. Remember, if it's symmetrical, think of like if my hand right here, and this is the line of symmetry, on the other side, it'll look the same, right? But it's not a slide or a glide, right? It's symmetric on both sides. So the distance from my thumb to the pen on one side of the line and the distance from my thumb to the pen on the other side is going to be the same. So you can see right here, a little bit different. It says if A is equal to B, then B is equal to A. If AB is equal to CD for a segment, then CD is equal to AB. We don't change the letters around, we change the entire order of the statements. The last one is transitive property. This one says, look, if A is equal to B, B is equal to C, then A is equal to C. Think about, maybe an example would be thinking about people's height. I could say if A is Alex, if Alex is equal in height to Brad, and Brad is equal in height to Craig, then Craig and Adam happens to be the same height. I think that's what I said for A for Adam. So there you go. It applies to segments and angle measures. We're making a connection between three different variables, or three different parts, or three different angles. Step one right here, let's solve the equation and justify each step. Let me show you what I expect you to do for each problem. Okay, right here, the first piece, we can go ahead and say the equation is given. All right, good practice. Whatever we start with, that is given. So however you want to solve this, that's up to you. And so that's why there are multiple ways of getting the correct answer here, especially when we're solving an equation. Let me go ahead and I'll start by adding 7 to both sides. So by adding 7 to both sides, I'll go ahead and underneath given, I'll go ahead and put addition. And I'll put POE for property of equality. We're going to go ahead, we simplify this, and so we now have 3x is equal to 5x minus 12. Okay. So we have our addition property of equality. Next up, if I want to get x by itself, we can go ahead and subtract 5x to both sides. So I have now the subtraction, and I'll abbreviate that, property of equality. So now I have negative 2x is equal to negative 12. Lastly, we go ahead and I want to use the division property of equality. So I want to divide both sides by negative 2, and now I end up with x is equal to 6. And there you have it. We have all our steps, and I justified them. When we do two-column proofs, they'll be set up the same way. We have the statements on one side, the reasons on the other. Okay, we have our statements of what we actually did. We have the reasons on the right side. Justification. Okay, let's take a look next up at number 2. My first step, or the first step you should take right here on number 2, is distributing. Okay, and what students often fail to forget is to distribute not just the 2 but the negative 2 here. Okay, so we start off with what's given, and what I'm going to go ahead and do is distribute. And so we have 20 minus 6x plus 2 is equal to x minus 6. I could do several things, but let's go ahead, let's kind of clean things up. And so how about this 20 plus 2? So I got 22 minus 6x is equal to x minus 6. And we can go ahead and say we're going to simplify that. Okay. Next up, let's go ahead, I'll add 6 to both sides. And that would be the addition property of equality. And so I have 28 is minus 6x is equal to x. I'll add 6x to both sides. And we have ourselves our addition property of equality again. And then I'll write things out over here where we got 28 is equal to 7x. And then lastly, we'll divide both sides by 7. We have our division property of equality. And x is equal to 4. And voila. All right, division property of equality. So now we've justified and solved the equations. Next up, let's figure out how we could solve an equation right here. Let's take a look at the first one, number 4. And they're going to ask you to solve for a particular variable. So this is pretty much you're using your geometry, or sorry, your algebra to solve things out. Okay. Justify each step along the way. Once again, good problem right here. If I want to get y by itself, I would subtract 9x to both sides. So we have our subtraction property of equality. So 2y is equal to negative 9x plus 5. Then we're going to go ahead, we're going to divide both sides by 2. And remember, you divide everything by 2. I always tend to want to put everything underneath the fraction, divided by 2. So we have 9 halves x plus 5 halves. And there you have it. We have solved for y. Okay. Let's take a look at one last one right here. And we'll take a look at number 6. The formula for surface area S of a cone. Something that we're going to look at in second semester a lot more are surface areas of cones. And then it says where R is the radius and S is the slant height. We want to solve the formula for S and justify each step. All right. And we're not talking about the uppercase S, we are talking about the lowercase s. Things that I would do first right here, since I know that S happens to be attached to the pi r, let's go ahead and take pi r squared and let's subtract that to both sides. So we have our subtraction property of equality. So we have S minus pi r squared is equal to pi rs. Lastly, I want to get S by itself. And then so what I could do is the opposite of multiplying is to divide. So how about I divide both sides by pi r? And so we have our division property of equality. And now lowercase s is equal to S minus pi r squared all over pi r. Then it says right here, we want to find the slant height of the cone when the surface area is 220 square feet and the radius is 7 feet. Okay, so let's figure this out. Square feet, surface area. I see that as an important piece of information. And they give us the radius, which is 7. And so let's think. In this equation right here, I should be able to plug things in. For example, 220 for slant height, or sorry, surface area. We have pi, the radius right here. Let's plug that in. 7 squared plus pi times the radius, which is 7, and S is your slant height. So I've got everything done. Now I can go ahead and just find what S is. I could simplify things out. Also, the beauty of being able to solve equations is that you could have actually just plugged that into the equation that we found and be able to get your answer. But I like showing you many different things and many different ways of doing, working on these problems. And so let's go ahead and work that out. Let me look at one thing just in case. I do believe there's one error in the problem, which is the surface area. It's not supposed to be 220, but hey, that's what they gave us. I think if some of you have the actual workbook, they put 113. So that was something. So if some of you guys, that part is 113. It's not 220. If you're using the student journal, obviously that's going to be at 220. So let's go ahead and solve this out since we are looking at the student journal, what I gave you. And so we have 220 is equal to 49 pi plus 7 pi s. All right, and then so I'll go ahead. We should be able to solve this out. Pretty similar to what we already did right here. We'll subtract 49 pi to both sides. And then lastly, we'll divide both sides by 7 pi. What I'm just showing you right here, once again, is being able to solve and get a variable by itself, and hopefully you could plug this into your calculator correctly. You are going to have to be careful. I tend to use parentheses, and which you should use, because your calculator actually doesn't understand directions very well. It just knows that if you plug in your calculator 220 minus 49 pi, it's going to divide that 49 pi by 7 pi. So using parentheses is actually very good practice. And if you don't believe it, hopefully you will soon enough, because you're going to get answers that are going to be wrong, and you're saying, well, what gives? And what ends up giving is the fact that you did the problem incorrectly. Or you did the problem correct, but you didn't plug it in correctly, and that happens to be user error. So what I end up getting right here is your slant height is approximately 300 or 3.004. They do ask you to approximate to the nearest tenth, which will get us to 3.0, and then we have feet. And there you go, we have found the slant height. If you know how to put your algebra to good use, you can solve for any variable here. You might have to find the radius, and hey, that is also possible. All right, there we go with section 2.4.